So arkadaşlar, until now we talked about Fourier series for continuous time signals and Fourier series for discrete time signals. What was specific about Fourier series? Yasir Çiben.
Sorry, hocam.
What was specific about Fourier series? Why did we use Fourier series for continuous time or discrete time signals? What was specific about them?
I don't really know, hocam, sorry.
Ama ben üzülüyorum şu anda. Yani o zaman hiç ders anlatmayalım. Gerçekten çok üzülüyorum yani. Hani bunlar çok temel sorular. Yasir, it is very fundamental. Why do we use Fourier series? You don't know this? What is specific about Fourier series? What's the difference between Fourier series and Fourier transform? Peki, Nur Efşan, what is specific about Fourier series?
It consists of sine and cosine.
What was specific about, like, what kind of signals do we work on for when we are talking about Fourier series? Periodic signals, right? We talk about periodic signals. Like if you remember, if my signal is periodic and if my signal is continuous time, we were using Fourier series. Okay? If my signal was periodic and if my signal was discrete time, we were saying Fourier series for discrete signals or discrete Fourier transform. Okay? So Fourier series is related to periodic signals. Anyone who doesn't remember this basic idea? Arkadaşlar. Who doesn't remember this basic idea? Now I will start discussing about aperiodic signals. Okay, aperiodic signals. And you gave me this during the in-class exercise you had a couple of weeks ago. If you remember this, you told me you have given this, and my question was why do we have different types of Fourier transform, right? That was my question. And like 99% of you have shown me this 2x2 matrix. This part is related to periodic signals, which is related to Fourier series. It was like related to omega 0 or omega 0, which is like our fundamental frequency or fundamental period. Here we will have omega and omega. There will be no periodicity in this case, okay? Now, from now on, I will mainly talk about aperiodic signals. That means we don't have to care about their periodicity. There is no period in these signals, okay? There is no repetition. In this week, we will be focusing on continuous Fourier transform. If you remember, we were talking about periodic signals. But what was critical here? I have discrete frequency spectrum. Why? Why do I have discrete frequency spectrum when I have a periodic signal?
We are looking for periodical signals. It's like one angular frequency to angular frequency of the R signal.
So if we are, thank you, Emre, if we are trying to plot our frequency spectrum, we will say this is 0, this is omega 0, 2 omega 0, 3 omega 0. So Fourier series representation show us the coefficients at certain integer multiples of our fundamental frequency, right? You remember this, arkadaşlar? Yes, I hope so. So there is a period whose period is t. There is a omega 0, it is angular frequency 2 pi over t. Okay, it's radians per second. And we have a frequency which is like 1 over t. Okay, so in this case, we have an omega 0, and in Fourier series representation, we always try to find out the multiples of these omega zeros. We also call them harmonics. Frequency components at each harmonic. Firdevs asked one question. Hocam, if there is no periodicity, I think in FFT there should be just a straight line. Why do you think, Firdevs, that's the case? No periodicity, I think in FFT there should be just a straight line. What do you mean by that?
Hocam, I understand that in FFT we see the some frequency values in our signal.
Yes.
And if there is no periodic signal, we have no frequency components on it, I think.
Today, in the next 10 minutes, I will try to change this idea, okay? I will try to work on this idea and try to give you a different perspective. So if we are talking about periodic signals, as you say, we should have at certain frequencies, certain components, but for aperiodic signals, we will start with the same thing, but we will come up with another type of representation, which we will call continuous time Fourier transform for aperiodic signals. So even in that case, I will have Fourier coefficients, but they won't be discrete anymore. Okay, it won't be discrete. It will be continuous. For the aperiodic signals, the frequency spectrum will be continuous. The signal will be continuous, frequency spectrum will be continuous. In Fourier series, my signal is continuous. Okay, this is continuous time signal. This frequency spectrum will be discrete. Okay, if you remember, like this was how we represent the Fourier series. Do you remember these formulations, arkadaşlar? Yes? We did lots of things on these. This was a 0. This is the average value or DC value. This was my function, and I was only discussing, or I was only focusing on the period, one period, okay? Even though it is like a signal which is infinitely long, I'm only focusing on the period, one period, okay? And the complex form that we had was like Cn times e to the power j omega 0 Tn, okay? This n was like the harmonics, first harmonic, second harmonic, third harmonic. And for each harmonic, I will have one coefficient. And I will add up all these harmonics, all these sines and cosines, and obtain my function. This is what Fourier transform says. Okay, if you remember, this e to the j omega was like cosine omega 0 and t plus j sine omega 0 and t. So this representation is highly similar to this representation. They are actually showing us the same thing, okay? Now let's try to derive how we deal with aperiodic signals, okay? How we deal with aperiodic signals. Let's start with a periodic signal like that. What's the frequency or the period of the signal? T, right? T seconds. Now, what happens if t goes to infinity? Arkadaşlar, what happens if t goes to infinity? Zübeyir? What happens if t goes to infinity?
We just have only one.
Very nice. We will just have this one, right? We will only have this signal. These will disappear because they repeat this after infinite seconds. That means they will just disappear. I will only have this signal and it will be aperiodic with a period of t equals infinity seconds. Buradaki başlangıcı anladık mı acaba? Did you understand this initiation of this the demonstration of continuous time Fourier transform concept?
Yes.
Yes. So we start with a periodic signal and we say, okay, let's say t goes to infinity. What happens? Okay, then we will be talking about a different way of looking at things. This time I will have an aperiodic signal, okay? These are for periodic signals, right? These are for periodic signals. And then I will not go into detail here. Bakın, here, burası kritik. Now, this delta V is like omega 0 is equal to 2 pi over t. T goes to infinity. If you remember from calculus, if this goes to infinity, what happens to this one? Delta omega, what happens to this delta omega?
Becomes 0.
It converges to 0, right? It becomes very small. As t goes to infinity, delta omega becomes very, very small, which converges to 0. Bakın, what did we do here? I took this formulation, okay? And I put, instead of the Cn, my regular Cn, let's say, equation. I put it over here. You see this? Okay, I put over here, and this one comes here. And then I will instead of this t here, I will write omega t is, what is 1 over t? Omega 0 over 2 pi, right? Omega 0 is here, 2 pi is here. Arkadaşlar, what am I trying to do? I have started from Fourier series representations, Fourier series here, and I will finally come up with Fourier integral, which is gonna be for continuous time Fourier transform for aperiodic signals. Okay, so this is what I'm trying to develop right now, and then for as t goes to infinity, this becomes omega 0 becomes like delta omega, okay? Very small right now. And then what happens to my formulation? If I have sigma and delta omega, it becomes integration, the summation becomes integration, and delta omega becomes d omega. Right, arkadaşlar? hani ne yapıyorduk? If I have the summation of a times delta x, if delta x goes to 0, then it becomes like a times dx from some point to another point. Like summation is converted to an integration by having this delta x converge to 0. It is not going to be converging to 0, but it's going to be a value which is like dx. Dx means very small x. Okay. So then what happens? Now I have this formulation. Okay. So now I have this guy here, Fourier integral. I have my signal here. I have 1 over pi, 1 over 2 pi as a coefficient. Two integrals. Okay. What is this part gonna be like? My coefficients, Fourier coefficients. Okay. Let me show you this, which we will call fj omega. Yani we will say this is fj omega, then it will be like 1 over 2 pi fj omega e to the power j omega t d omega. Okay, so what does this mean? My coefficients will be multiplied by, if you remember, how was my formulation? Cn e to the power j omega 0 and t, and this was my signal ft. Now instead of Cn, I will have fj omega, which is a continuous function right now. This was discrete. This is continuous function. Okay, this is like a function of omega, which by using this integration I will find out the coefficients. Okay, how was my Cn calculated? Like f of t e to the power minus j omega 0 and t dt, right? This is like 1 over t. That was my formulation. Now instead of Cn, I will write fj omega. Instead of ft, I will put f of t again. Instead of e to the power minus j omega 0 and t, it will be, there is no n anymore. Okay, there is no n because there is no harmonics. There is only one t which goes to infinity. There is no repetition anymore. That's why I come up with a new omega, okay, which doesn't depend on a certain fundamental frequency and its harmonics. I have now omega, which is a continuous variable. Anlıyor muyuz arkadaşlar burayı?
Yes,
So
hocam.
from now on, this is like Fourier series. Let me show you here. I hope you're gonna see better by these things. Can you see the relationship between these two cases? This is for periodic signals with period omega 0, and n omega 0 will be the harmonics. That means integer multiples of our fundamental frequency. Here I have an aperiodic signal, okay, and my omega is this is like a discrete variable. I will have omega 0, 2 omega 0, 3 omega 0. Here I will have omega as a continuous variable. There is no like harmonics anymore. Okay. So the function, or like this is synthesis equation, synthesis. because we are synthesizing our signal using different sines and cosines, let's say. Here we are analyzing analysis equation. We are analyzing how much different frequency components I have for each omega value. Okay?
Hocam,
Efendim?
for the Fourier integral, how can we go with first line to second line? Actually, it's like, I don't understand the exact relationship synthesis and analysis. How can we get each other from their basis?
You wanna say this one?
Yeah, for example, for this one, it is not like an integral relationship. I don't know, how can we get this equation?
This was how we got that. So bakın, I say this is my coefficients and I leave them as a separate definition. Okay? I start from here. Bakın şuradan geldik. Tekrar gösterelim. I started from here. Periodic signal. Fourier series representations. Then I say now instead of Cn, I will put this function here, this equation, and I will come up with such an equation right now. Yani we are following the steps one by one. Only trick that I have done, instead of t, I have written 2 pi omega 0 over 2 pi. Okay, then 1 over 2 pi goes out, omega 0 stays here, but as t goes to infinity, omega 0 goes to 0. That's why I say delta omega. Okay, now bakın, so what is my f of t here? This is my function. This is my coefficients. Aynı bakın, coefficients times e to the pi, e to the coefficients times e to the j omega. Coefficients times e to the j omega. And there is summation here. There is no summation anymore. Instead, I have integration. So if you do this on your own, you're gonna improve or enhance your understanding. But what I'm trying to say here is that it's a really easy way of deriving a new formulation by which you don't have any periodicity in your signal anymore, but you have a continuous variable which is called omega. Okay? Bilemedim Emre, açıklayabildim mi acaba sorunu, cevabını?
Yes, hocam. Yes, hocam, thank you.
I start from Fourier series and then I just put instead of each thing and then come up with a formulation. Okay. Now what am I gonna do here? I'm gonna, arkadaşlar, deal with these formulations on Wednesday around 4:30. We will come together and then start solving some questions together. I want you to understand how you would deal with Fourier transform questions, okay? For example, I will deal with, let me show you one example. For example, before we talked about this periodic signal, right? This was my periodic signal like that. I had this periodic signal, but here I won't have any periodic signals anymore. I will have only one square pulse. And how shall I find out the Fourier transform coefficients or Fourier spectrum of such a signal? That's what we will be doing on Wednesday and Thursday. Okay? Evet arkadaşlar, time is up. I know you have classes after this, and any questions at this point, please try to, I will share these slides with you, and I want you to go over them on your own, and then we will be practicing together what the topics that you would have difficulty with. Okay, so it's not a very difficult topic. Just knowing what you're doing is the key at this